Um, so this is part 2 of the midterm review, and I've fixed up question 43. I think it makes more sense now. So the question is, suppose I put this formula in cell E1 and then copy it down to cell E2, and here's the formula. What formula will cell E2 contain? Well, okay, the thing to notice is that unlike in the previous question, this uses relative addresses. So when I move the formula to a cell one row down, everything in the formula should also move one row down. And because we kept it in the same column, it should stay in the same column. So that would give us answer C. All right, the next section is true-false. So changing the name property of a button changes what you see on the screen when you run the program. That's false. The name is what you use in the program when you're programming. It doesn't show up on the screen. On the other hand, changing the caption property of a button does change what you see on the screen, so that one's true. A local variable can only be used in its own subprocedure where it is declared. That is true. A global variable cannot be used in a subprocedure. False. Global variable can be used all over the place. A local variable can have the same name as a global variable. That's true, though it's not necessarily a good idea. Usually not. Two local variables in different subprocedures can have the same name. True, and that's a big advantage of local variables. Two local variables in the same subprocedure can have the same name. No. Within a subprocedure, all the names have to be different. If a variable is only used in one subprocedure, it should be a local variable of that subprocedure. And that one's true. Has to do with our rule of making things local whenever possible. Okay. Now, in the next question, we start referring to buttons. And those are buttons that are found in the midterm review spreadsheet, which is posted. And you can see there are a ton of buttons here. And what it does is it lets you test out the code that's being asked about in the question, so you can see for yourself what it does. And if you don't understand it, step through it. So step by step. I am going to close this up right now, but it's there for you to use. Okay, so here, let's consider this code fragment. And it wants to know what is the final value of x, y, and z. Well, the best way to do this is to make some notes over to the side about what's happening. So here we have x equal 1 and y equal 2. Okay, so here, x equals 1 plus 2. So on this line, we get x equals 3. Okay, now we're going to change y. Y equals y plus x. So 2 plus 3, y equals 5. Okay, now z equals y plus x. New value of y, though. So, well, x plus y, same difference. So here, this lets us z equals 8. And now x equals x plus 1. Last time we changed x, it was 3. So now we have x equals 4. All right, what is the, and notice, changing x here does not change anything about lines where we used it before we changed it. Okay, so what is the final value of x? It's 4, so that's B. What is the final value of y? It's 5, so that's C. What is the final value of z? Well, it's 8, so none of the above, E. Okay, next. How many values can be represented with 1 bit? 2 values, right? It can be 0 or 1. What about with 2 bits? Well, then we have 4 patterns. That's E. What about with 3 bits? Doubling from the previous one. We're going to get 8, also 2 to the 3rd power. What about with 8 bits? Well, this is 2 to the 8th power. That's 256, so it's D. You should know all of these up to 10. Or at least put them on your notes. What data type do you use for a counting number? Integer, B. What do you use for a number for general computations? Double, that's A. What do you use for a logical value? D, Boolean. What do you use for a quantity that is a quoted text? That would be a string, type C. Okay. Using the operator plus, we're going to get a double or an integer because you can use it in expressions of either type. The / divide, that's always going to give a double. The integer divide should give us an integer. The operator ampersand is used with strings, so it will be a string. The operator greater than. Okay, this one's interesting. You can use it on numbers or strings, but it comes out true or false, so the answer is a Boolean. The operator not, also a Boolean. And the operator exponent gives us a double. Okay, here's another way of asking these questions. So the type of this expression, I know because I used an ampersand that it's got to be a string. I must have been working on strings. And this asks that same question. Another way, it's anything I'm using in an operation with an ampersand should be a string. Okay, this guy, because I'm using mod, it's an integer, because mod is an integer operator. Same thing here, we should be using an integer. And this one, again, a logical expression, it will be true or false, so it's Boolean, which is D. All right. A text box starts out with a blue background and no text. Use the following choices to answer the questions. So after I do this, what is the color of the text box? Well, here I'm setting its background color to be VB yellow. So it'll be yellow. B. And what does it say? Well, I put the text hello in it, so that'll be C. Okay. For this one, what is the color of the text box? Well, this doesn't change the color. It starts out blue, so it's staying blue. So that'll be A. And in this one, it starts out blank. We put in the text hello, and then we put in the text goodbye. So it's the last one we put in. Remember, when you reassign a value, it wipes out the old one. Okay. Finally, you have to be really careful here. This one's tricky. I changed the color, but not the color of the text box, right? So because of that, it's still going to be blue, which is B, I think. Let me double check. No. A. Good thing I checked. Sorry. And what does it say? It says hello, which is C. Okay. Now we have a conditional statement here. We want to know what's the value of var C after this code executes. Well, so it's asking, is A bigger than B? Is A bigger than B? No. So we're going to do this one and set var C to be 2, so the answer is little a. All right. If x is true, then not x is false. If x is false, then not x is true. If x and y are both true, then x and y is also true. But remember, if one of them is false, like x, then it's false. If x and y are both true, x or y is true. If x is false and y is true, it's still true. With the or, at least one has to be true. On the other hand, if they're both false, it'll be false. All right. If x and y are both true, then x or y is also true. Then we're doing the not, so that'll make it false. Now here I think the best idea is to go ahead and complete the truth table. So let's do that. So for not x, we just reverse x. So we're going to get false, false, true, true. Okay, not X or Y. So I'll be using these two columns. And so this will be true because the Y is true. False because they're both false. True, they're both true. True, then not X is true. Okay, X or Y. I'll use the X and Y columns. So I'll get true because they're both true. Another true because X is true. Another true because Y is true. And then false when they're both false. Now the not of this, I just reverse it. So I'll get false. Whoops, sorry. False, false, and true. And now I want the and of the expression not X or Y, this guy, and the expression not X or Y, this guy. So this column, and my rule is they both have to be true, otherwise I get a false. So false, 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 and the last one is true. Okay, and now I can answer this. If X and Y are both true, it's the first row. The top row, it's false. Let's make a space there. If X and Y are both false, it's the bottom row, true. X is true and Y is false. That one's false, and this one is also false. Make sure you can work those truth tables. Okay. What's the value of RC after this executes? Well, here you have to evaluate a little more complex if with a little more complex condition. So A is 2 and B is 3. A is not bigger than B, but A plus B, 5, is bigger than 4. So this compound condition is true. So we're going to do var C equals 10, and that will be E. All right. What if X equals 4? Well, 4 is less than or equal to 5. So the answer will be, we'll do this one and we'll get the 25. So that is A. What if X equals 7? This one's not true. This one is true. So we'll get the 15, which is B. What if X is 12? Not true, true. So we get the 15. But you might say, what about this one? Well, there's no such thing as more true. The first one that's true, we do. So we get the 15. That's B again. What if X equals 6? Well, it's not less than or equal to 5. It's not bigger than 6. It's not bigger than 10. So it doesn't change. We started it out at 0, so it'll be 0 still. And that is D. And I see I'm going to have to do a part 3. So we'll stop this one now and pick up with part 3 soon. Go back to where I was there. Okay, see you then.